projectile is any object that travels through the air with a combination of two different types of motion. The two different types of motion are accelerated motion in the y direction and uniform motion in the x.
An example of a projectile is a cat jumping off a ledge. As he travels along his trajectory, he has a uniform motion in the x direction and accelerated motion in the y.
Along his trajectory, we were able to acquire the necessary measurements to complete the following calculations. We were able to measure our range to be 0.4 meters and our distance in the y to be 1.19 meters. Using a stopwatch, we measured the time it took for the cat to reach the ground from its starting point to be 0.382 seconds. Since we were able to measure dx and t, we could then solve for the velocity in the x direction using the kinematics formula of velocity is equal to distance over time. Our values for this formula are distance being 0.4 meters and time being 0.382 seconds. This gives us a velocity in the x of 1.047 meters per second. Our rounded velocity in the x direction is 1.05 meters per second.
Where he started from rest, his first velocity in the y direction is 0 meters per second. Because the only force acting on the cat is gravity, we also know that our acceleration is going to be negative 9.81 meters per second squared. With these measured values, we are able to use the kinematics formula v2 equals v1 plus at to solve for v2y. Using our formula, we have v2 is equal to 0 meters per second plus our negative 9.81 meters per second squared times our 0.382 seconds. This leaves us with a final velocity of 3.75 meters per second. We have found our velocity in the x direction to be 1.05 meters per second, while our final velocity in the y direction was 3.75 meters per second. What we have left to find is our net velocity. We can find our net velocity using a combination of Pythagorean theorem and trigonometry. Using the Pythagorean theorem will give us the magnitude of our net velocity. So we have c squared is equal to 1.05 meters per second squared plus 3.75 meters per second squared. When we add this together, we get c squared is equal to 15.165. When we take the square root of 15.165, we will get c. We calculated our c to be 3.89 meters per second. In order to get our direction, we need to use trigonometry. We're able to use tan because we have the values for both our opposite and our adjacent. So we have inverse tan times theta is equal to our v2y, which is 3.75, divided by our vx, which is 1.05. This gives us an angle of 75 degrees. We had a net velocity of 3.89 meters per second, 75 degrees south of east. We were able to repeat this process to find the velocity of several other points along his trajectory.
In this simulation, you can observe his vector values along his trajectory. During his first point, he has a Vx of 1.05 meters per second, a Vy of 0.00 meters per second, and a net velocity of 1.05 meters per second east. At the second point along his trajectory, his velocity in the x direction remains the same, and his velocity in the y is 1.25 meters per second, with a net velocity of 1.63 meters per second, 50 degrees south of east. By his third point, he has a Vy of 2.50 meters per second, a Vnet of 2.71 meters per second, 67 degrees south of east, as the velocity in the x stays the same. Finally, at his last point, we know his Vx is 1.05 meters per second, his velocity in the y direction is 3.75 meters per second, and he has a net velocity of 3.89 meters per second, 75 degrees south of east.